So let's begin with Newton's first law of motion. But before that, let's do a quick recap on what's a force. In the simplest terms, a force is a push or pull exerted on a body having some mass. Measured in newtons, some common examples of forces are friction, which acts on the opposite direction of the body in motion. Then we have the normal, or the reaction force, which acts perpendicular to the body in contact with another body. And weight, which is the force exerted by gravity on a mass. Now, Newton's first law of motion is actually a restatement of Galileo's law of inertia, but Newton got the credit for it, so that sucks, but that's another story for now. The law states that an object at rest tends to stay at rest, or if it's moving with a constant velocity, it will keep moving with the same velocity unless an external net force acts on it. So there is no resultant force on the body since all the forces are balanced out. For example, here's a ball lying on a flat surface. It's at rest. There are no forces acting on it because weight and reaction forces are already balanced out. So the ball will stay at rest for as long as you can imagine, unless there's some form of wind resistance or any other kind of force which gives it acceleration and makes it move. So that's easy. Now, Galileo imagined a marble rolling in a frictionless bowl. He observed that it will always roll up to the same height on the opposite side of the bowl, thanks to the conservation of energy. Now he imagined an infinitely long bowl. If you drop the marble ball and let it roll, it will keep on moving with a constant velocity till it reaches the same height on the opposite side. But it never does, so it keeps on moving forever with the same velocity. Unless there was any kind of external force which makes it accelerate or decelerate, it will keep on moving with the same velocity forever. This is where Galileo came up with the thesis for his law of inertia, which Newton took the credit for. Newton's second law of motion is concerned when there are unbalanced forces acting on a body. So there is a net resultant force which creates some form of acceleration or deceleration on the body. This law gives us the very famous formula: force equals mass times acceleration, where force is a vector and acceleration is a vector. For example, if a ball of mass 1 kg is accelerating at 9.8 meter per second squared, force is going to be 1 times 9.8, which is 9.8 kg meter per second squared, which is 9.8 newtons. So in other words, it takes 9.8 newtons to accelerate a ball of mass 1 kg at the rate of 9.8 meter per second squared. So a body experiences acceleration if a net force is applied to it. Acceleration is proportional to the force applied on the body and inversely proportional to the mass of the body. Last but not the least, we have Newton's third law of motion. It says that for every action, there is an equal and opposite reaction. So say you hit someone double your size with a force of certain newton, you receive an equal and opposite force in your direction. Now since force depends on mass and you're lighter than the man itself, you will receive a greater force because the greater the mass, the stronger the force. So you might hurt your hand or fall back. Another very common example is the recoil of the gun. When you shoot, the gun exerts a force on the bullet. So according to the third law of motion, the bullet must also exert an equal and opposite force on the gun. This is the force which makes the gun recoil and you move back.